Hello friends, you are watching Data Structures using C. All the videos are brought to you by Ankpro Training from Ankpro Technologies. So friends, in this class we will be learning the third type of linked list, that is doubly linked list. If you are new to this video, I recommend you to please go and watch our previous videos where we have explained the linked list and the circular linked list. Okay, so if you know the basics of C programming like structures, pointers and functions, you will find these videos very easy. If you don't know what are those concepts, please go and watch our C programming playlist. Right, so we'll start our today's class by understanding what is the doubly linked list. A double linked list is a two-way list in which all nodes will have two links. So this is same as the single linked list, but the only difference is this is two-way list. That means each node contains three fields. That is one field extra than the circular linked list or the normal linked list. The fields are left link, data and the right link. Okay. This helps accessing both successor node and predecessor node from the given node position. Right. So doubly linked list means each node in the list will hold the address of its predecessor node and also the address of the successor node. So in that way we can access any node in the list going forward or moving backward. Okay. So now let us understand the memory structure of the doubly linked list. Right. So this is a single node with a start pointer. So this node is called as the doubly linked list node. Right. So this node has got three fields. One is the previous pointer, another one is the next pointer. So since this is the first node in the list, the previous pointer or the left pointer has got null data, because this left pointer is not pointing any node at all, because this is the first node, there is no node before this, right? So this is the right pointer. In the left pointer, it has got the address of its next node, address of the successor node, right? So the address of this first node is 1000, which is stored in the start pointer, right? So this is the second node in the doubly linked list, which has got the address 1002, which is stored in this first node, right? So the address of the first node is 1000, that is stored in the right pointer, right link of the second node. The address of the second node is 1002, that is stored in the left link of the first node. So in this way, the second node is pointing to the first node and first node is pointing to the second node. So they both are circularly connected. So the address, the left link of the second node is pointing to the third node, and the right link of the third node is pointing to the previous node. That means the address of the second node is stored in the third node, right? So the address of the third node is stored in the second node. So this is the last node of the doubly linked list, which has got null data, which has got null in its left pointer, left link, right? So this is how the doubly linked list looks like. So here it is null because there is no node after the last node, right? So it is representing itself as the terminating node of the list, right? So these are the operations that we are going to perform on the doubly linked list. Create a new node. Before creating the list, we will create a new node and we'll create a list of nodes with data stored in it, and create a new node at the beginning. If we have created only one node, we will create a new node at the beginning, or we can create a new node at the end, or we can create a new node after any particular node. We can delete a node at the beginning, delete a node at the end, or delete a node after any particular node, and we can also traverse through the doubly linked list, right? So let us understand each of these operations. So first we'll understand the C code to define a node, right? So here we are using the struct, right? So structure is going to define the doubly linked list. So DL linked list is the name of the structure. So this entire thing is representing one node. The left pointer stores the address of the successor node, and right link or the right pointer stores the address of the predecessor node. The data of the node, this field stores the actual data stored in that node, right? So these three components are part of the one single node. So here it is the node. So this is representing the structure, or structure is representing this node, right? And we are using the typedef to give a simple name to this entire thing, because struct dl linked list will be a longer name whenever we want to access this node. So we are just redefining the name of this structure. Typedef struct dl linked list node. This means we are giving a new name to this structure, which is node. So now node is the name of this structure. Whenever I call node, I'm calling this entire structure, right? So this is the another name of node, is another name of this entire structure, that is DL linked list, right? So I'll create one more pointer called start. So this is the start pointer which initially holds null, right? So start, we have created a start which holds the null before pointing to the first node. So this is the node, right? So now we'll understand the C code to create a new node. Since we have just understood how to define a new node using the structure, now we actually write a code to create a new node. So we are now just going to create a single node, okay? So node star get node. So this function get node is going to create a new node, and the return type of this is node. Because node represents the entire structure, we are going to create a node which is same as the structure. That is why the return type of this function is node, and asterisk also because this is going to return the address of the newly created node. That's fine. So inside here I'm going to create a new pointer called a new node which holds the address of the newly created node, right? So this is also type of node, right? I'm using the malloc function to create a new block representing the structure. So the size of node will calculate this size or the memory required for the structure ultimately representing the node, which is consists of three parts, right? So I'm going to calculate the memory required for one node. So malloc function will reserve the block or create a block same as the node, okay? It has been created, and it will return the address of that newly created node to new node. So now new node has got the address of the newly created node, and the return type of this address is node, right? So node is representing the structure, and to hold the address of that structure, the return type must also be of type node, right? So after this, I'll tell the user to enter data, so that will be stored in address of new data arrow data. New data is the address of the newly created node. Arrow data represents the data field of that newly created structure or the node. So I'll initialize the left link of the new node with null and right link of the new node with also null, right? And I'll return the new node. So new node has got the address of the newly created node, which is a simple one node. So that is looks like this. So this is the new node which have been created just now. So the data field contains the data entered by the user, and left is initialized with null and right is also initialized with null. So I'm going to return the address of this newly created node to whatever function which calls this function, right? Now we'll understand how to create a doubly linked list of n number of nodes, right? Okay, now we are going to create a list, right? So create list is a function which takes a parameter of n. N represents the total number of nodes that is going to be created. Okay, n is an integer, say suppose 3, 4 or 5, anything. So that is the total number of elements that we are going to create now, right? Int I need this to run the loop, to run the for loop. So here I'm going to create two temporary variables. One is new node, another one is temp. I'll tell you why I'm using these two temporary pointers. So I'm running for loop because I'm going to create n number of nodes. To create n number of nodes, I'm running this for loop. At each iteration, I will create one single node using the getNode function. So here inside I'm using the getNode function. So we have just discussed the getNode function, which creates a new node and returns the address of that newly created node that is going to be stored in the new node, which is a local variable, local pointer here, right? So new node has got the address of the newly created block, right? So if start equals to null, I will store the address stored in the new node into the start. So this is the status of my list. So this is the new node which I've just created, and start is the pointer which is pointing to this node. If start equals to null, if this is null, I'll store the address of this node to null, right? If at the first case, so this is no longer null, this is now pointing to this node, right? If so, there are two cases. One is creating the first node. So this is the first case. The second case is creating the nodes when there are already some nodes. Say suppose this already been created, right? So this is now created. So how to add more nodes to the existing node, to the existing list? So here it is. If start equals to null, this will be executed. If start is not equals to null, that means there is a node in the list. So at that time, this else part will be executed. So temp equals to start. I'll create the, so this is the right, this is the temp variable. This is going to be this is going to hold the address stored in the start. That means this is indirectly pointing to the first node, right? So to insert a new node in the list, I have to traverse till the end, right? I have to get the address of the last node so that I can insert a new node at the end of that list, right? So that is how I can add the node to the existing list, right? Right. So while temp of right not equal to null, temp of right link, this thing, until this remains null, I'm going to run this while loop. So I'm continuously storing the temp of right again into the temp so that it will point to the next node every time, right? So is this so temp arrow right is equal to null? No, not, right? So I'll store the temp of right again into the temp. That means whatever it is pointing to, the address of the next node is again going to be stored in temp. Now temp is pointing some other node in the list, right? So it will go on pointing all the nodes in the list, and it reaches one node which has got null in its right link, right? At that time this will fail, and I will move to the next statement which says temp of right. Temp of right, let's suppose this is the last node, right? So which is here. So temp of right is new node. Whatever the node which has been just created, the address of that node is going to store in the right part of the temp. So here this will hold the address of the newly created node, making that node as the next node in the list. And I will store the content of temp into the new node arrow left. So this is the new node. So temp is currently pointing to the previous node of this new node. So I will store the address of that node here in this part. So by that I'll make this node as the last node of the list. Right. I hope you understood this code. So this is the last node. Right. Right. So let us imagine I have created this list into this list, and I have to traverse through the list. I have to traverse throughout the list, displaying each and every node in the list. So let us see the code for that. So traverse function will execute. I'll create a temp variable here. Let us say this is the temp pointer. Temp will hold the address of start. That means it is currently pointing to the first node. So the content of the list are, if start equals to null, if start equals to null, there is no node in the list is empty. Else, I'm going to print the content of temp arrow data. So until temp not equals to null, until temp not equals to null, until it remains not pointing to temp, not pointing to null, right? Right. Now temp is currently pointing here. So I will print temp arrow data, which is 10, and I will make temp to point to next node by storing the right part of temp again into temp. What is the right part of temp? 1002. So I will store 1002 in temp. So at that time this no longer point here, this will point 1004. So that is stored in here, that is stored in temp. Is temp not equal to null? Yes, temp is not equal to null. Then print temp of data. Print this part. Print number 10. Next, temp of right again in temp. What is temp of right? 1004. Again store that in temp, which is pointing here. Is temp not equal to null? Yes, it is. So print temp of data. Print this 10 now. Again store temp arrow right again in temp. So now temp is pointing here. Right. So temp is printed now null. So temp is now pointing null. That means temp holds null in it. Is temp not equal to null? No. Now temp is equal to null. Then get out of the low. So I have successfully printed all the nodes. I hope you understood this program. I mean the code to traverse throughout the linked list. Right. So now let's discuss the C code to insert a node at beginning. So let's imagine there are some nodes in the list, and there may be no node in the list also. So let us consider both the cases. Okay, this insert at big function will insert a new node in the beginning. So first I'll create a temporary variable called new node, and I'll use that node to store the newly created node's address. So I'll use the getNode function, which creates and returns the new node for me. So that address of this is now stored in new node. So this is now new node, right? So this has been created. How to insert in the list? So let us discuss that. If start equals to null, if this is equals to null, we have created, but we are checking whether the list is null or there are any nodes in the list. If this is null, so I will simply make start equal to null. That means if there is no node in the list, I'll simply make this node to point this node, right? Otherwise, else what I'll make this pointer, right pointer of the new node to point to this node. That means start arrow left, and new node's address inside start arrow next, like this. and I'll make start arrow to point to this and the null in the left. I don't need to put the null in left because by default it is null here when the new node is created. So let us discuss that. So else new node of right equals to start. What is the content of the start? 1000. So that will be stored in the new node of right here. So now new node of right is currently pointing to this node. Yes. Next. So the start of no. What I need to do now? I need to store the address of new node inside start arrow left. Right? Address of the new node inside start arrow left. So now this address, the start of arrow left will point to this new node. Now both are connected. Yes, that is what we have wanted. And start equal to new node. Address of new node will be in start and start will point to this new node. So this will become the first node in the list. Right. I hope you understood this code. And now we'll see how to insert a node at end. Let's imagine this situation. Now I'm going to insert a new node at the end of this list. And there may be two cases. First case is maybe this is null, or there may be one node, or there may be several nodes, right? Insert at end. I'll create two variables here. One is new node, another one is temp, and I'll use getNode function to create a new node. Yes, and this has been created now, and it has returned this node. I want to insert it at the end of the list. Okay, if start equals to null, I'll simply make this node to be pointed by the start. Yes, whenever the start is null. Otherwise what I have to make? I have to iterate until the last node. So I'll use the temp node, I'll use the temp variable to start from here and iterate until it reaches null, and I will make temp arrow left to point to this node, and I will store new node's address in temp arrow left, and I will make this as null. Yes, that is what I wanted. So I'll store the content of start into temp. So now temp will start pointing the first node, and I have to make this temp traverse till the end, right? So I will make use of this for loop to iterate through the loop until temp arrow right remains not equals to null. I will use I'll traverse until the end, right? And making every time temp to point to next node. Temp arrow right will be again stored in temp, that is temp will point here, temp will point here. Whenever it reaches here, temp arrow right not equal to null? No, this time it is null. So you will get out of the loop. Now temp is currently pointing to the last node. Yes, so imagine this situation now. So this is the current situation now. Yes, what happens next? I'll simply store the new node address inside temp arrow right. Now this is the temp arrow right. This is now currently pointing this node. Yes. And the address of temp inside new arrow left. This is new arrow left. This is now pointing to this previous node. So null will be stored here because this is the last node of the list. Okay. So now we'll understand the C code to insert after a particular node. I mean anywhere in the middle of the list. Okay. And this will take three parameters. One is the address of the start node that is stored in the start pointer and the target node. So how to calculate the target node now? For that I need to have a function to find out the target node, after which I want to insert the new node, right? So there is a function. Okay. So there is a function which calculates, which finds out the target node. So this function find a node. So this function finds the target node, after which I'm going to create a new node, right? So this will take the start pointer and the data to find the node. So how it finds? It creates a new variable, pointer variable called temp, and I will make that if start equals to null, return null. There is no node, telling the target element not found. And if that doesn't happen, I will make the t to point the first node. While t remains not equals to null, I'll iterate till the end. If t arrow data equals to data, that means this is the target data, I will return t. So t has found, the target node has found. If not, if that doesn't happen, I will make t arrow left to point to the next node every time until it reaches the null. So every time if the data is found, I'll make this, I'll return the t. Simply I'll return the t. Yes. Okay. So now get back to the function. Let us imagine the target element has found, and that is returned to this function. Okay. Now I'll create a new node which is going to be inserted in the middle of the list. Yes, if target equals to null, which is returned by the previous function, invalid insertion, else I'm going to create a new node using the getNode function. So this is the return type of that function. So one node has been returned and the data has been stored inside the data field. Now I'll store the target address of the target node inside left part of the new node. Let us say suppose this is our target node, after which I'm going to insert this new node. So address of this node will be stored in the left link of the new node. So that means the left link is now pointing to this node, and the target arrow right, that means uh, what is there in right part of target? Address of next node, right? So address of the next node will be stored in right part of the new node. So this node is now pointing to this node. Okay, so making this node to be in between the target node and the next node. So I have made. Okay, if target arrow right not equals to null, when target node is the last node, so at that time target arrow right equals to null, right? So I'm checking whether target arrow right not equals to null. If this is not equals to null, if this is not the last node, I will store the new address of the new data. I will store the address of the new node inside target arrow right, arrow left. That is target arrow right is this. Left part of this is this thing, right? So now here it is targeting, it is pointing this node. Otherwise, if this is not happened, I will store the new node's address inside target's right. Target's right is this, so this will point here. Yes. If target arrow right is equal to null, if this is equal to null, also the target arrow right will point to this node, right? At any case, this will be in the middle of these two nodes. And now delete the first node. Okay, so how to delete the first node? First I'll make use of the temporary node. If start equals to null, then empty list get ch, right? Else if there are nodes, how to delete the nodes, how to delete the first node among those nodes? So I'll start by storing the content of temp inside content of start inside temp, thereby making the temp to point first node, and the start of right inside start, right? What is the start of right? The address of the next node. So this will point here. And start of left equals to null. What is start of left? This thing. So I will store null here. Now I'll free temp. So if I free temp, this will be deleted. So look here, this will be the first node, and the left part of this has got null in it, right? Moving on, how to delete the last node? There may be two situations. The one is there is only one node other situation is there are many nodes, right? So delete a last node. So again I'll create the temporary variable. If start equals to null, empty list, otherwise I will store the content of the start inside temp, thereby making temp to point to first node, and I'll iterate through the list until it reaches null. Until temp right reaches null, I'll iterate, making every time temp to point to the next node. So whenever it reaches null, I mean the last node, so whenever it reaches null, this gets a fail, right? You will come out of the loop. So when you come out of the loop, I will store temp arrow left. This thing, this is the temp arrow left. Arrow right. So arrow right means this thing to null. So I will store null here, right? So this will be null, and I will simply free the temp. If I free the temp, this will be deleted. I mean the last node will be deleted. So now let's study the code for deleting a node after a particular node, right? So this is our function, and this will take two parameters. One is the start pointer and another one is the address of the target node, right? So first we are checking if start equals to null, then simply tell list is empty, you can't delete a node, right? And what happens if our target node is the first node? Say user has entered to delete this node, right? If the target node is first node, I will check is target of left is null. So this is my target node. This is the target pointer. If target arrow left is equal to null, yes, so this is the first node, then simply store the target arrow right inside start. What is the target arrow right? Target arrow right is the address of the next node. So store that address inside start. So now start will point to the next node, right? And store the null inside target right arrow left. What is target arrow right? Target arrow right is 1002. That means this node. Arrow left means here, this part. So store null inside here, so that this will become the first node, right? So let us do that and free target. If I free target, this will be deleted, right? So this will be deleted. Okay. So this is the first case and return 1. So if our target element is last node, say suppose I want to delete this last node, so I will check. So this won't happen. If target arrow right equals to null, if target arrow right equals to null, then that will be the last node. So from that I'll recognize that node as the last node. So in that case, so I will store target arrow right, which is null, inside target arrow left arrow right. That means target arrow left is this, address of 1004 is this, right? So here target arrow left is this, arrow right is this 1006, right? So in that case I will store null inside target arrow left arrow right. So I will store null here and I'll simply free the target. If I free the target, this will be removed and return 1. Okay. Okay, so these are the two cases. What if I want to delete any intermediate node? Say suppose my target is this. In this case, I have to store the address of 1006 here, right? So this has to point this and this has to point this, right? I will make this if my target element is this, right? Okay, let us do that. So first, so this is the default case. When these are not working, I will go with this. Target arrow right. Target arrow right is 1006. Store this 1006 inside target arrow left arrow right here. Store 1006 here so that this will point to this. And target arrow left. What is target arrow left? 1002. Store the address of 1002 inside target right arrow left. Target right is this, arrow left is this thing. So this will point 1002, right? So this is what happened. And free target. Now if I free target, this will be removed and return 1. So this is the code for deleting a node after a particular node. I hope you understood this code. Please take down and pause the every code, each and every code that I have explained here, and make up a new program. Well friends, that's it for the class. Subscribe to our channel on YouTube, like our page on Facebook, follow us on Twitter, and join our group on LinkedIn. Thank you.